Hi there, this is Jake Nash, Algebra Lessons, and that's the first time I've had my intro sound on there, so sorry that wasn't so good. But today there's music in the background, not music I'm playing. It's music that a family member is playing that it's not my favorite music, but I don't want to ask her to turn it off because I will just annoy her. So, there you go. This is Unit 1, Lesson 1. On arithmetic sequences. So we're now not in the Unit 0 where it's Algebra 1 review, which anyways, a lot of the things that we learn in Algebra 2 are review, but it's just based on it and more. Like if you take a world language, when you go into Spanish 2, it's going to be pretty much the same things as Spanish 1, but it's going to build upon those, and that's what you do. Because remember, this is Algebra 2. So, arithmetic sequences, that might ring a bell. You might have even learned that in elementary school. So that's basically just when you have a series of numbers, and they increase by the same amount, but you do that by adding, not by multiplying. Multiplying, that's a different thing, and that's not what we're learning in this video. So, I'm trying to look at some written out notes that work good for this. So yes, it's based on addition or subtraction. You can sometimes subtract things too. And the difference between the numbers is called the common difference. It's actually represented with a D for the equations that we'll use. So, D, let's just say that. And let's see, what would the common difference be for certain things? So let's see. 5, 8, 11, 14. What's the difference between these numbers? To get to 5 to 8, you add 3. 8 to 11, add 3. 11 to 14, add 3. So that means that D equals 3. There we go. That's simple. That's all I need to say. So, and the same would go if it was negative. So, -6, -10, -14. It's -4 each time. There you go. That's what the common difference would be in that situation. But sometimes it's not just that simple. You might see a series of numbers. For example, 4, 6, 8, 10, and it's like find. This is term 1, 2, 3, and 4. Find term number 579. Oh, what the heck? There's an easy way to do that without having to do that. Look for each one. That would take forever. So there's a simple equation we can use that would work for that, okay? So there's two equations that we can use. We first have the arithmetic term formula. Arithmetic. Also, this is sometimes called explicit, so you can see either one. And the equation for this is we'll talk about what these things mean. AN equals A1 plus N minus 1, and then times D. So here's what the things mean. AN is what you're trying to find. A1 is the first term in the series. So for A1, you plug in the first number of the series. So if it was 1, 2, 3, then A1 is just 1. Now, N is the number of what you're trying to find. So in the example, we used 579, so you might plug in that for there. And then D is the common difference between the terms. So let's look at an example using this formula. So let's say we had 1, 5, 9, 13. What is term number 68? Okay, so let's plug in A1. First term is 1, so we just plug in 1. Plus N, we're trying to find number 68, minus 1 times the common difference, you add 4 each time, so it's positive 4. But I'm not going to say that because that looks like plus, and it's really times. So let's put that into the equation. So we have 1 plus 67 times 4. We get 269. So in this series, 269 would be the 68th term. There you go. Simple. So that's that equation. But there's also another one that's kind of like dumb, but sometimes you still might have to use it, and it's called recursive. And why I think it's dumb is because it's not really helpful unless you know the term that's before what you're trying to find. So let me show you what I mean. So this one's an equals a subscript n minus 1 plus d. So the same variables mean things, but for that same example, we're trying you would need to know the previous term in this case. So you wouldn't really be able to use this one in that situation because you didn't know what was before that. Now we would know that if it was 269, then that term would be 265 if you subtract 4. But anyways, those are those two formulas that you will use. Sorry about that. Sometimes you might have to change the formula to a different form, but that won't be discussed in this video. Because that's kind of what we already did, like with the literal equations. And that would be it for this video. Thank you for watching, and see the next video on functions.